Implementing the Telephone Butler has an easy part and a hard part. The easy part is the implementation of the butler itself. Yes, I was interrupted by a robocall in the middle of making a presentation on stopping robocalls. So implementing the butler, it has an easy part and a hard part. The easy part is implementing the butler itself, actually. First, we need to redirect all the user's calls from the existing telephone number to a data center, or the cloud, as it's now called. That's quite easy because a telephone number doesn't actually describe the telephone line anymore, and hasn't since Strowger switching gear was abandoned about 30 years ago. All the telephone number is a label in a database called SS7 that maps the telephone number that you dial to the place where the call could go. And that is used to create features like local number portability, lawful intercept, wiretapping, 800 numbers, a whole range of features that the modern telephone system offers. Once it's in the data center, the call is received by the butler, which is simply a metaphor for a software agent, or a computer program as we used to call them. And that computer program then tries to anticipate what the user would want to do with it, which might range from accepting the call now and being alerted by summoned by a bell, through to rejecting the call completely, or somewhere in between. It might go into voicemail. It might go to voicemail and be converted to text by a voice-to-text converter. That happens with a lot of my mail that goes to my business line because I don't actually have a telephone on it. In some cases, yes, we might even have a use for capture, but that's got to be a very sparing use, or else we'll make more problems when we solve. That part of the problem is relatively straightforward because we're not going to try and solve it now once and forever, and we don't need to. There will be multiple butlers on offer. There will be a competitive market in developing effective filtering techniques, and there'll be a constant battle to negate whatever the latest countermeasures the attackers have come up with. The key to good spam filtering in email is not one good idea or one good algorithm. It's the ability to monitor what you're doing and how effectively you're eliminating the spam on a continuous basis, identifying which techniques work, which don't, applying the most effective ones, and constantly generating new techniques to counter new attacks. It's a dynamic system, and it's all based on feedback. Implementing the Telephone Butler is the easy part. The hard part is how do we provide the butler with the information they need to do their job. They can't anticipate the user's needs without feedback from the user, and that presents us with a usability problem. The second piece of information we need is intelligence on the bad actors that are out there in robocaller land. Getting the information from the user is hard because this device, the telephone handset, is a miserable excuse for a user experience, and it basically hasn't changed since Strowger invented the rotary dial. Okay, you push the button instead of turn a dial, but doing three-way calling on one of these things is an exercise in frustration. It's a hack. It's not a usability experience, it's a complete hack. And not only is it a stupid set of arcane numbers that you have to type in, they change from one provider to another. So I've just changed my telephone provider and I can't use three-way dialing because I don't know what the call is for the new one. And of course all the stuff from the new provider went in the bin because it's paper, and they don't have it on their website anywhere I can see. So I've got these features, three-way dialing, I can't use them, I don't use them. If the butler is going to be effective against robocallers, the user's got to be able to summon the butler when they need. And in particular, we've got to get feedback on this is a robocall, because we are going to rely on the end subscriber's receiving the robocalls and then reporting them as spam, because if we don't have any feedback in our system, we don't have any way of measuring which techniques are effective and which don't. And we've got no way of seeing whether problems are arising and how we need to respond to them. So getting that user feedback is absolutely essential for our system to hang together. Now, one thing that we could do on this thing is to reserve one star code that would be the same across all providers, and this would be by regulation, and that star code would summon the butler, and then we'd have a voice command interface. I mean, speech recognition has now got to the point where simple telephone commands work quite well. They're slow and they are really frustrating because the feedback is poor. But they could be better designed, and with better speech interfaces, and more importantly speech interfaces that are tailored to the end user, maybe that could be made acceptable. Acceptability is critical here because if this is going to be an offering that users are going to feel good about, they have to enjoy using it. Another alternative would be, just as we have smartphones, we might have smart handsets. In fact, if the abuse comes in on a mobile call, it doesn't happen to me that often now, but as robocall becomes increasingly criminal, it will start to become a bigger problem. We could add buttons to this interface really easy because it's all in software. All we need is some sort of agreement to have an agreement on adding buttons so that Apple and Google and Nokia and Motorola and all the rest can add them together. I'd like to do the same thing for the telephone handset in the home and call them super handsets, and maybe this would just be your telephone handset. Maybe it would also be your remote control for your television and your HVAC and all the rest of it and so on. But that would allow us a more expansive user interface, something that allows the user to program in things such as hold all my calls but just for the next 5 hours. Right? My current telephone system allows me to turn off calls during the night, but it's an all or nothing proposition. I can't turn off all the calls except the calls from the people who should be in the house, and if they're not in the house, well, it's because there's a big problem. If my daughter is calling me at 3 o'clock in the morning, it's because there's a problem. So we need to have the ability to provide nuanced information, and that really demands some sort of rich interface like this. Now at the moment, this is obviously a $600 piece of technology, but that's a piece of technology whose price can and will come down. If you look at the new requirements for a handset, I believe you could probably make one today for in the region of $100, which sounds a heck of a lot, but in a couple of years that will be down even further. And another part of the thing is, if we're trying to create an infrastructure, an ecosystem, well, there's a whole mass of early adopters out there for whom being able to buy a gadget is actually rather an advantage. I think my wife might think I am one. The final part of our problem is we need to know about the abusive callers, and in particular we need to prevent them from hiding in the internet and the telephone network by just creating an infinite number of access points under which they can hide. The telephone infrastructure has a mechanism called caller ID. There's another one called AIN, and they're what provide the telephone number that appears on your handset when you call. There's just one problem there, and that is that system is completely insecure. The telephone number just comes out of a technical process where a database somewhere says, oh yeah, this is the number that's called. And if you're an attacker and you know how to produce robocalls, well, spoofing caller ID is actually quite easy. You can look up instructions on how to do it on the internet. I won't go into it now. So what we need to do is to use a technology called public key infrastructure to authenticate the callers. And here we have another problem. Now, I work for a provider of public key infrastructure, but this is not a presentation on their behalf. I spent almost 20 years now working on public key infrastructure. Public key infrastructure is a very compelling technology, it's a very powerful technology, it's a seductive technology, and it's also a very difficult one to deploy on a large scale and to a high degree of fidelity. Deploying PKI at internet scale has only really been achieved once. We achieved it for the SSL system, the system that provides you with padlocks and green bars when you visit websites. That PKI is a very elaborate, very extensive piece of technology that has a lot of moving parts, a lot of complexity, and a lot of legal considerations built in. It's an important and a useful infrastructure, but that's not an infrastructure that I think that we can deploy fast enough and on a consistent enough basis, quickly enough, to solve the robocalling problem as quickly as we need to. Fortunately, I think there might be another way, and it's what I call scruffy PKI. And my inspiration here comes from Tim Berners-Lee, who I worked with at CERN. And when Tim was designing the web, there was a big question in the network hypertext community of how did you achieve what they called referential transparency. What that meant was that when you clicked on a hypertext link and it took you somewhere, how could you know that it wasn't going to break? You mustn't ever present the user with a message saying this is broken. And Tim, the reason that the web took off when other things didn't was that Tim came up with a solution to that problem, which was to say, no, don't solve it at all. The cost of creating a system where there will never ever be a broken link is much higher than the cost of dealing with the occasional broken link when it occurs. And so the big technological breakthrough that made the web work where our competitors didn't was actually 404 not found. The message that says you've got a broken link, we try and take you there, and didn't go. So the key there is that the key insight that Tim had was not what you do and what capabilities you give the system. It's what shortcuts you take, what you leave out. And what I think we need to leave out in the case of a PKI for the telephone system is the strong assurances that traditional X509 PKI provide. We're not going to be able to achieve end-to-end security in this system without a considerably higher degree of expense than I think that we can justify right now for robocalling. For some callers, the expense of achieving an end-to-end solution in a strong PKI is going to be more than justified. The legitimate bulk callers, like the people who called up to say that some medicine was ready while I was making the call earlier, those providers could be dealt with a strong PKI. But for the bulk of them, we've got to do something simpler, something that I call scruffy PKI. So what's a scruffy PKI? Instead of trying to create an unbroken chain of proof from one end to another, we allow there to be breaks in between. But each time we have a break, we have the person who's creating one message saying, well, this is the information that I acted on in creating it. This is not something that you would ever want to trust for a purpose like signing an electronic contract or transferring amounts of money. But it's perfectly adequate for an accountability-based system where what we're trying to do is to identify the purveyors of abuse. And so the solution there is to combine this strong PKI for the cases where it can work, and there's an existing network of certification authorities that can say, yes, this is a legitimate corporation that is going to make a bunch of robocalls for legitimate purposes, and this scruffy PKI, which would be telephone exchanges that create certificates for use within their own networks, and then explain to the receivers when messages hop from one network to another, there will be a continuity mechanism that will allow that context to be kept rather than lost, which is what happens at the moment. So there you have the solution. It consists, as far as the user is concerned, it's the electronic butler, and it is a mechanism to make the telephone network more polite and more appropriate to modern needs. It's not just about stopping the robocaller abuse, it's also about putting the user, the consumer, in control of the telephone services that they pay for. There's an easy part, which is how do we establish this software agent in the cloud? How do we establish a market for providing those services? And then there's two hard parts, which are how do we provide that information that it acts on from the user and from the infrastructure, so we can identify the bad actors and prevent them from having a place to hide. Thank you for your time, and hope to see you again. Oh, and if you want to build a Dalek, well, please don't argue.